So this is 5.5, equations with rational expressions. So what we're going to be doing here is we're going to have some division and finding common denominators in order to solve these. So let's get started with example 1. We have x over 2 minus 3 equals 2/3. Okay, so the key for solving all of these questions is finding the common denominator. And once we find the common denominator, we will multiply the entire equation by that common denominator. So let's make them all fractions. And if we look at this particular one, we see that the common denominator of 2, 1, and 3 is 6. So we're going to multiply the entire thing by 6, which means we're going to distribute that 6 to everything. So let's just do this, and I know it's a time-consuming process, and it gets worse as we go when we have more stuff there. So we can either cancel before we multiply or after we multiply. I prefer doing it before. So that's a 1 and that's a 3. 6 over 2 is 3. And this one is 18. And that equals 1, 2. 2 times 2 is 4. All right, so let's move everything to the left side of the equation. So that's always the next step. Okay, now we're going to add everything, or we're going to add the 22 to both sides so that we can isolate the variable. And we get our answer there of 22/3. When we have some problems, like starting in example 2, we run into some problems that have variables in them, and that makes things not necessarily more difficult, but you just have to think through a little bit about what's going on. Now, when you have a variable like we do here, finding common denominators is a lot easier because you're not looking at what is the common denominator of 3 and 2. You're finding the common denominator of 8 and a minus 4, which just means you put the two together. So we're going to multiply the entire thing by 8 and a minus 4. So what that'll look like and that equals, back to black, 8 a minus 4 times 3 over 8. All right, so what happens then is whenever we multiply by the common denominator, all of our fractions will go away. We'll be able to cancel. And then here we're left with 48, and here we're left with a minus 4 times 3. If we do distribution, okay, now we end up moving the 48 over, or the 12 over by adding 12 to both sides. And we have 60 equals 3a, and our a then equals 20. And that's pretty much the key that we're trying to do here. The key plan is to multiply both sides by the common denominator. So let's look at one that's a little more intense, example number 3. Okay, so our common denominator, these are already common, so we just need one of those, and we've got a 3. So our common denominator is the 3 and the x minus 2. So we're going to multiply the whole thing by 3 and x minus 2. All right, so this next step, it is pretty important to do this next step, even though it's time consuming. It just keeps things nice and orderly. And it's not because I like to write. Okay, let's put these in parentheses. And 3x minus 2 times 2 over x minus 2. All right, so we can cancel this one and this one. If we can't cancel all of the denominators, we did something wrong. So that kind of helps you to get an idea of what's going on here. Okay, I switched that. I put that in the front just because it's easier for me to distribute that way. And 3 times 2. So 3x plus 2x minus 4 equals 6. So I'm going to bring my 3x and my 2x together. And I'm going to add 4 to both sides. And that gives me 10. My x equals 2. Okay, so that ends up being my answer. But one of the things that I want to make sure that you start looking at, because we have these denominators with x's in them, they can cause a little bit of a struggle. Because what happens is if we put this 2 back into this original equation, and let me do this in blue. So instead of the x, I'm going to put a 2 here. I'm going to put a 2 there. Okay, notice what happens. This 2, when I subtract it, I get 0. That's undefined. When I do it here, I get 0 on the denominator. That's undefined. So actually, when I put 2 in there, even though algebraically it works, it is undefined. There is no answer. And when there's no solution to the equation, when I put it back in, we have what is called an extraneous solution. Now later on, when we're dealing with square roots, it'll be called an extraneous root. Ones that work algebraically, but when you put them back in, they don't work. So it's very important to check your answers with the original, because you're going to get an answer like 2 here and think, oh yes, I did well, it's done. But you've got to put that back in here and check, because that may not even be the answer. The answer may be an extraneous root. Okay, let's jump up to example number 4. We have 5 over Okay, one of the things to remember is you're always going to factor. That is always the first step you take, because our common denominator would be a mess. So let's go ahead and factor this denominator. Okay, and this one is already factored. And this one is 1 over, and let's pull out a 3. All right, so let's look at what we need. We have an x minus 2, and we have a 3. Those are the only things that are different. Everything else, we've got an x minus 1 here and here, and x minus 2 here and here. So those, we just pick one of those. So those are the only things that are different that we have to pull out. So let me slide this over a little bit. So we're going to multiply our entire equation by, x minus 1 too. So there's an x minus 2, an x minus 1, and a 3. So let's pull all of those out. Okay, so like I say, when we multiply, and this gets to be the long doldrums here, times okay, and the same thing and I can make this smaller so that I can get it all on one page. Okay, now I go around and cancel. I can cancel both of these with both of these. This one with that one. And both of those with the 3 and that. All right, so again, it gets rid of all your denominators. That's the only reason you do that step. Well, plus it just makes life a lot easier. Okay, so 15 minus 3x plus 3 equals x minus 2. And let's see, what are we going to do? Negative 3x plus 18, 15 and 3. Okay. So let's move the x over. So that gives me a negative 4x plus 18 equals negative 2. And let's go ahead and move the 18 over. Trying to isolate that variable. Divide by negative 4. X equals 5. So we plug that back in the original problem and we find out that it works. So we're good to go there. So the next one, example 5. Let's go ahead and do 3 plus 1 over x equals 10 over x squared. We're going to make that a 3 over 1. What's the common denominator here? The common denominator is not x and x squared. So there's 1x here. There's 2 x's here. So that is all we're going to multiply the entire thing by. So if we have variables in the denominator that have exponents, the exponent that we're going to multiply the entire thing by is going to be the highest exponent. So let's go ahead and multiply each one of these. So I'm just going to write it all out again. Okay, then I cancel. Cancel that with one of those. Cancel both of those. So we have 3x squared plus x equals 10. And I'm going to subtract 10 from both sides because I've got a squared there. So I'm going to make it into a trinomial, quadratic equation there. And then I'm going to break this down into 2 binomials. So remember, you multiply the 3 times the negative 10, you get negative 30. 2 numbers multiplied together give you negative 30. Added give you a positive 1. And when we group and put all that together, we've done that over and over before, so I'm not going to take time to go over that again. But we get that. I'm sorry, 5. Or negative 4. 3x minus 5, x plus 2. So 3x minus 5 equals 0. X plus 2 equals 0. So x here equals negative 2. And x here equals 5 over 3. So we try both of those. And find out they both work. They both make this equation right here a true statement. So we're good to go by saying that those are both of the answers. All right, so that's it for this video. We'll finish up and hopefully the next one.